Hello everybody, this is Dr. Pennington. This is a intro video for Chemistry 1152 TLC lab. TLC, in case you guys are wondering, stands for thin layer chromatography, not tender loving care. There won't be any of that in this lab. TLC, we're going to be using it to analyze some mixtures and see what we have. We have aspirin, we have Tylenol, we have caffeine, and then we have two unknowns. These unknowns are Excedrin and anisine, and we don't know which is which. We're going to use TLC to figure it out. The other things that we need to complete this experiment are a couple of TLC plates, and I'm going to give you some more detail about preparing these in a minute, and this TLC jar that's got some sand and some TLC solvent in the bottom. We'll also need a pair of tweezers. There is a UV lamp that's somewhere around here. I'll show you guys that too. We'll also need a ruler and a pencil, all right? Okay guys, so this video shows my two TLC plates, and you can see I've got some stuff written on these. There is the plate on the left that has A and B written on it. This plate is for unknowns A and B. And I'm going to spot A above letter A, I'm going to spot B above letter B. On the other plate, I have spots for C, T, and AS, caffeine, Tylenol, and aspirin. So the way I prepared these TLC plates is by drawing a pencil line, a straight pencil line about close to 1 centimeter from the bottom, and then repeated exactly the same thing on the next plate. And then another line about 0.5 centimeter from the top, more or less. It doesn't matter exactly what the distance is, but provided you can get it about the same for each plate, because you're going to be comparing these side by side under the UV lamp, so you want them to look as similar as possible. This is what your two TLC plates will look like. Now I'm going to go through the process of how I actually spot them. I have my 3 samples in little glass vials here. These are just solutions of each of the 3 knowns, caffeine, Tylenol, and aspirin, in a solvent. I think I use methanol. I'm going to spot them on the TLC plate with this thin piece of glass here. This is called a capillary tube. All I'm going to do is dip it. This is my caffeine solution. I'm just going to dip the capillary tube into the solvent mixture where the caffeine is, and then I'm going to carefully dip it. And now I don't think you guys are going to be able to see anything here, but what I'm actually going to dip, I'm actually going to spot right on the pencil line at the bottom that I told you guys about. So where the letters C, T, and AS are for the caffeine, Tylenol, and aspirin, I'm going to spot right on that line. You want to make sure you spot at exactly the same height for each of the 3 compounds. All right. Where I spot, again, you probably can't see it on the video, but it goes a little bit dark where I've spotted, because that's the methanol spreading out. Now, we have to make sure we use 1 separate capillary tube per compound, because we don't want to get we don't want to get 2 compounds showing up in the same place by accident. We don't want contamination. That's what the word I'm looking for. All right, I did that for caffeine. I'm going to do exactly the same thing for Tylenol, and I'm going to spot it right on the line again. And I'm going to do the last thing for aspirin, and I'm going to spot my unknowns in exactly the same way. I'm not going to show a video for that because it's exactly the same as here. The next video that you guys will see, I'll show you what this plate looks like under the UV lamp, because right now, if I shake this, so I'm just shaking it to make sure all my solvent has evaporated. What I want you guys to see is that although I've spotted 3 compounds on here, you can't actually see anything. And that's because you've spotted white compounds on a white background, all right? So you can't see anything, but we can under the UV lamp. I have the 2 TLC plates that I just prepared. They're under the UV lamp. Now, they don't look like anything special because I haven't turned the lamp on yet. Right now, all you see is 2 blank TLC plates. When I turn on the UV light though, you'll see the plates will go green and spots will show up. Now, hopefully you guys can see that there are 5 spots on those plates, 1 above C, T, AS, and A and B. The compounds in these chemicals have a certain chemical structure that allows them to fluoresce under UV light, and that's exactly what causes these dark spots that you see. So when we put these plates into the TLC chambers and the solvents pull them up, these spots will still be present, but they'll be at different places because they'll have risen up the TLC plate. All right, guys, now I have my 2 TLC plates prepared. I prepared them both in exactly the way that I showed you in the previous video. And now I'm going to take each of my 2 plates, as I drop one, I'm going to take each of my 2 plates and put them into a TLC chamber. And these have in them sand on the bottom for a level surface, and then a liquid, a solvent above that. And so what happens is, as the TLC plate goes into the solvent rises up, and depending on the chemical makeup of each spot on there, it'll get pulled up with the solvent or it'll stick to the plate. So the point is that each spot will rise up a different distance. And you want to make sure that you keep each of these TLC plates in the jars until the solvent rises to the top line that was marked in the first place. The only reason I'm doing that is so the solvent's rising up exactly the same distance in each of my 2 plates, all right? So I want to make sure that I'm careful about putting the plate in exactly flat relative to the level of the solvent, so I have to be careful here. Now we could put more than 1 plate into 1 jar, but it's easier just to put 1 plate in 1 jar, so I'm just putting this in and I drop it down. The solvent is slowly making its way up the top of the plate, and it's going to take the compounds with it to some degree. So the plate I just put in the TLC jar was the caffeine, Tylenol, and aspirin. And now I'm going to do the same thing with my unknowns A and B. Notice I'm using the tweezers because it's much easier to put the plate in carefully using tweezers. In each case, I was careful putting the TLC plate in flat, because what you don't want is to put the plate in crooked and have the solvent going up the plate not straight. So now all we do is wait, all right? Now we could just have me leave this video and have me just stare at the camera for a few minutes, but that's rather boring. So, goodbye. So I just showed you guys the 2 TLC plates being put into their TLC chambers. Time has elapsed. The solvent's gone all the way to the top line, and so, at least on this first one. So I'm just gonna take it out. I'm using the tweezers to take it out. And because this is full of solvent, I'm just gonna shake it because I want that solvent to come off, and I just want it to dry. There's no point in putting this under the UV lamp with lots of wet solvent on it because it's just gonna look like a mess. So I'm just gonna let this dry. Gonna take just a little bit to dry. And then once this is done, I'll dry the other one, and then I'll show you what these will look like under the UV lamp. You've already seen what they look like previously under the UV lamp with all the spots at the bottom, and now you'll get to see what they look like after they've gone, or after the solvents have gone up through the TLC plates, all right? All right, so these are the 2 TLC plates that I've run through the UV lamp, through the TLC chambers, all right? Remember what they looked like before? Well, this is what they look like now. You can see that those spots are still there, but can you guys see that they have moved? Those spots are all in different places. And the position of each spot gives us a good idea of being able to tell what exactly is what. So what we're gonna do is, this video is just so you guys can see what these plates look like. And ordinarily what you guys would do at this time is circle all these spots and then do some measurements. Now obviously you guys can't circle those because this is a video. I'm gonna circle these plates, these spots, and then I'll show you what the plates look like afterwards. But this in essence is thin layer chromatography. The spots have moved from where they were before. Okay guys, so what this video is showing are the 2 TLC plates with the spots marked. I'm sorry that the camera's moving around a little bit. I'm literally holding my phone above these plates. I've marked each of the spots with a dot, with a circle, okay? What I did was I literally drew a circle around each spot. And so the hope is what you can tell is caffeine, Tylenol, aspirin all move different distances up the TLC plate. And then unknowns A and B, you can tell what's in them. You can see how many spots are in A, you can see how many spots are in B. And hopefully you can tell something about the identity of each spot, all right? The actual calculations that you guys are going to do here, the retention factor calculations, those are in your experimental procedure. It's literally the distance traveled by the spot divided by the distance traveled by the solvent. And the distance traveled by the solvent is from the bottom line to the top line. The distance traveled by the spot is from the bottom line to the middle of the spot. And as both units will be centimeters or millimeters, then there won't be any units. That is in essence how to calculate an RF value. And with that, you can tell exactly which of my components, caffeine, Tylenol, and aspirin, are in each unknown A and B. And then hopefully with that information, you can figure out which unknown is which.